Hello, welcome to S2C's webinar series. In this session, we will cover debugging techniques for FPGA prototyping. Before we dive into details, let's first compare FPGA debugging and debugging for FPGA prototyping. Well, you may be asking yourself, aren't both cases using FPGAs? And are they really that different? Well, for one, if you're debugging a conventional FPGA design, you're most likely using your own custom board design with matching I/Os. And with FPGA prototyping, you would have to consider if matching daughter cards and connectivity are available. Secondly, you may already be familiar with debugging tools offered by FPGA vendors. And for prototyping solution vendors such as S2C, we offer additional tools to supplement or enhance the debugging productivity, especially when it comes to single FPGA debug versus multiple FPGA debug. Let's also spend a minute to look at the various validation techniques to see why having a good set of debugging tools is critical to FPGA prototyping. Essentially, validation approaches such as simulation or emulation provide high visibility. FPGA prototyping, on the other hand, offers extremely high performance at the cost of more limited visibility. Therefore, it is crucial to be familiar with available debugging approaches to maximize the value of FPGA prototyping. This is also the reason why commercially off-the-shelf FPGA prototyping is typically more productive than build-your-own solutions. In this session, we'll be covering 4 types of debugging approaches, including basic I/Os, AXI bus transactions, signal-level debugging, and lastly, protocol-based connectivity. It is very common for designs to use basic I/Os, such as push buttons or dip switches for resets or to toggle frequently used settings. LEDs are also useful as visual aids for status checks. GPIO and UARTs are also handy to interact with your designs. These types of I/Os can be found pre-built into S2C's prototyping boards. In addition, S2C's Player Pro software offers virtual operations for remote diagnostics. Another debugging approach is to leverage bus transactions to get data in and out of your designs. As many SoC designs nowadays have adopted AXI, S2C offers 2 types of connectivities over AXI. S2C provides a high bandwidth bus transaction connectivity called ProtoBridge. This setup offers approximately 6 GB per second bandwidth over PCIe. The ProtoBridge solution provides an AXI bridge in RTO format for you to interface with your test design. On the host PC, we provide PCIe device drivers and APIs for you to develop and interface with software-based stimuli. S2C will soon come out with a new solution with approximately 10 megabits per second bandwidth to allow quick and easy read and write access to memory map AXI slaves in your design over Ethernet. Signal-level debugging, including probing internal nets, is probably the most fundamental and the most widely used debugging approach. S2C's Player Pro software can easily bring internal signals to the top and to assign to I/Os. S2C also offers various daughter cards for convenient pin header connection, 3.3 volt translations, additional buttons and switches, and interface to external logic analyzers. S2C Player Pro also supports probing the nets with MDM, S2C's multi-FPGA debug module, which we will cover in coming slides. FPGA vendors also provide signal-level probing tools in their software. Both Xilinx and Intel offer solutions such as VIO IP Core and Sources and Probes Editor to monitor and drive nets via JTAG. Both vendors also will offer embedded logic analyzers such as IOA and SignalTag2, which sample the nets you want to capture and store them in FPGA's on-chip RAM blocks to be read out over JTAG. Embedded Logic Analyzer is great for single FPGA debugging, but when it comes to FPGA prototyping, not only does it consume valuable FPGA resources and has quite limiting trace depth, it is also very difficult to debug multiple FPGAs. To better support signal-level probing over multiple FPGAs, S2C offers multi-FPGA debug module. The newest MDM Pro supports concurrent probing of up to 8 FPGAs with multi-FPGA triggers. To enable deep tracing, MDM Pro comes with 64 GB of built-in DDR4. It also supports traces up to 16K nets in 8 groups of 2K probes without FPGA recompilation. To enhance productivity, Quad 10M and Quad 19P logic systems have MDM Pro hardware pre-built in. Trigger setups should be quite familiar, as they are quite similar to FPGA vendors' tools. MDM Pro supports both IP mode flow and compile mode flow to accommodate your design flow preference. Using the IP mode flow, designers can directly instantiate the MDM client into the RTL to interface with the signals to be captured. In the compile mode, designers can use Player Pro to specify the signals that are to be captured. As shown in the earlier slide, performance is FPGA prototyping's key feature, and it is common to interface with real-world data for in-system testing and debugging. S2C offers over 90 ready-to-use daughter cards and reference designs to facilitate various types of in-system protocol testings. If you have any specific needs, S2C can also work with you to provide you with the most optimal solution. In this session, we have covered a few common approaches for FPGA prototyping debugging. Tools like VIO-IP and sources and probes editors are directly available from FPGA vendors. Tools like Integrated Logic Analyzer and SignalTap2 are also available and great for FPGA debugging, but would not work so well over multiple FPGAs. S2C offers various debugging solutions ranging from basic I/O, UARTs, ProtoBridge, and NT-Bus to MDM Pro and daughter cards. And we hope these tools can help increase your productivity and shorten your validation cycle. For more information on ProtoBridge and NT-Bus, be sure on the lookout for upcoming webinars. And that's the end of our session. Thank you very much for watching.